All right, so we're back to our class lecture, and we mentioned, we mentioned the three factors that influence the weather. And the first thing that we said was thermal energy. The second was the uneven distribution of that thermal energy, and then the last thing was water vapor in the atmosphere. So we sort of started with the last thing, talking about water vapor, right, which is what clouds are in the atmosphere. With the exception of one type of cloud. One type of cloud is not actually vapor. Do you guys remember?
Is it cirrus?
Cirrus, right? So the cirrus one said is made of tiny ice crystals, right? And so, does that seem a little weird to you that ice would stay floating around up in the sky? Right? The reason that seems weird to us, though, is because, again, it's what we were talking about at the beginning of class. We're used to thinking of something that's solid as being heavy, and so it's going to fall because of that. But what did we say about water? Water is unique in that in its solid form, it floats on top of the liquid form. So if the liquid form can sit up in the air without falling down, right, for periods of time, then certainly the solid form, the ice form, can also do the same thing, right? Because the ice form is actually able to float on top of the liquid form. So let's talk about one of our other topics that affects the weather, and that's thermal energy. So we have light that comes from the sun, and we call it, so this incoming solar radiation. We have a word that we use, which is like an abbreviation based on different parts of this phrase right here. So we take the in from incoming, and the sol from solar, and then the Asian part from the end of radiation, and we make this word here, insolation. All right, and so insolation is our word that means the light that's coming from the sun to the earth. So this is the light coming from the sun to earth. So it's kind of a cool word. We don't normally have words that we use in English that are based on portions of other English words. It's not. Usually it's like you'll say it comes from Latin, or it comes from Greek or German or something like that. But this one's just a combination of three other words that we take pieces of and put together to make that word. We do that sometimes with other words too, but it's uncommon to see it with three words. And so there are really two things that affect the amount of insolation, what the Earth gets from the sun. So two factors affect insolation. Number one is the Earth's distance. Earth's distance from sun. Right? It should make sense that if we're closer or further away, that we're going to get more of this radiation from the sun. And when you think of radiation now, don't think of, we tend to think radioactive. When we talk about radiation, and we always think of it as being a bad thing, but it's just the light that's coming in. It's not, it doesn't always mean like radioactive in the sense that we're talking about dangerous radiation. So the Earth's distance from the sun affects that insolation, and the other thing is Earth's tilt on its axis, or we call this the axial tilt. And this is on average 23.5 degrees. That's how much the Earth is tilted on its axis. I'm going to go get a globe. Let me go grab that real quick. So this is why globes are, hey, let's see if we can do this on the video. So the Earth is rotating. Just rotating around the sun. Wasn't that cool? So Natalie got to see that come by. Here, we're going to reverse motion. Oh, look, the Earth is going the other way, Natalie. Okay. So that's why you see globes, right? Where they're tilted like this. Where we've got that line through the middle, and it's tilted at 23.5 degrees on there. And just something to note about the Earth. So, we know that the sun sits in the middle, right? You guys impressed by my sun? It's pretty awesome, huh? Yeah, okay, nice. And it's not a perfectly circular orbit. When the Earth rotates or orbits around the sun, it's more of an ellipse. Now, it's not that, here's the Earth. It's not that elliptical, but just had to flatten it out some in the drawing so that you could see it was an ellipse. It's actually closer to being a circle than it is an ellipse. Or that elliptical anyway. But there's a drawing, he's got a similar drawing on page 162. So we'll refer to that, especially as we talk about some of these other pieces of this. But so the Earth is on an ellipse. Ellipse is, are you familiar with the term ellipse? Have you heard that before? It's just another term for an oval, right? So it's on this elliptical orbit. And one other thing to note, so these are the things that affect the insolation, but I do want you to know this. Cloud cover reflects insolation, right? So how much of this solar radiation that we're getting coming to the Earth is definitely dependent on the two factors that we've listed here, the Earth's distance and the Earth's tilt, but the weather on the Earth can also affect how much of it gets through, right? Because if there's a lot of cloud cover, that insolation is going to be reflected in that portion of the Earth at that time. Is not going to get as much insolation. And there's two really kind of weird sounding terms that I need to define for you. Aphelion is the first one. So aphelion, and then the second one is perihelion. Perihelion. So aphelion is the point at which Earth is farthest from sun. And when it's at this point, you get on average 3% less insolation. Right? So that's aphelion, and then perihelion is the point that is closest to sun. and get 3% more insulation when that's the case. Right, so make sure you know those two terms. So you might think that because of this, that this is predominantly why we have different seasons. It would sort of make sense that if the Earth is further away from the sun at certain times of the year, right, as it's orbiting the sun. I mean, why do we define a year to be 365.25 days? It's 365, but every 4 years we have a leap year, right? And the reason we do that is because the exact time for a year is not 365 days, but it's 365.25 days, 365 and a quarter. Why? Why did we define that as a year? Do you guys know?
No.
It's because that's how long it takes for the Earth to orbit around the sun. All right? So you ever heard anybody say when you have a birthday, like, how old are you guys? How old are you?
13.
13, you're?
I'm turning 14 in a couple weeks.
You're about to be 14? Okay. So when you hit 14, someone might say to you, it's always like the older generation that says this, congratulations on making 14 trips around the sun. You ever heard that term? No? Okay. Maybe a grandparent will say that to you or something. Right? Nope. But that's what they're talking about. Because it takes a year to go around the sun. So when you turn another year older, because you've already been inside your mother's womb, and we know life begins at conception, right? You've actually already hit that point where you've been that many years around the moon. But outside the womb, you've been that many years, made that many trips around the sun, because it takes a year to go all the way around the sun for the Earth to do that. And so if during that year, right, if the path of the Earth is not perfectly circular, and so sometimes we're closer to the sun than we are at other times, you might think, well, that's probably why it's colder certain times of the year and warmer other times of the year, because we're closer during certain times and we're further away from, we would expect that the closer times would be the warmer months and that the times that we're further away are the colder months. But if you think about it, if the Earth is on this elliptical path, there's like 2 times that it's closer, and there's 2 times that it's further away, right? And so if that was what was causing the seasons, then we would expect us to have 2 times of the year that are the cold times of the year, right? That are equally cold, and then 2 times a year that are equally warm. So it's not really this that's the main reason that we have seasons. Do you guys know why of these 2 things? Well, if it's not the first one, what's the only thing that it must be that really causes the seasons? It's the second part, right? It's really the Earth's tilt on its axis that causes our season. Its tilt along with its path around the sun, okay? So if you think about it like this, so let's see. Well, we've got, so this is maybe kind of easier to see if I cut this light out. And you guys, somebody shine a flashlight on here for me. That's a little too, maybe like that. All right, yeah. So shine that on the Earth there. Got a nice little shadow on the back end there. It makes sense to you, and you can see it. Let me kind of turn it. I'll tell you what, I'll do it like this actually. Put it here, so maybe you guys can kind of see it better. So, am I in the actual light? Sort of? Yes?
That Earth
Huh?
on the camera is kind of like...
Is it like this? Is that better? Yeah, okay. All right, so can you kind of see this is the bright side, right? This is the dark side over here. And what the Earth is doing and so we think of our light source as the sun, right? That's where the sun is over there. The Earth is taking this track around the sun as it's orbiting around, right? Fairly slowly, but it's traveling a lot. It's when I say slowly, for this little simple diagram, it seems like it's moving slowly because it's got to take a year for it to get all the way around the sun and come back around. But it's traveling a tremendous amount of distance, so it's actually moving very fast through space. But we've got this light that's shining on there, and as the Earth is rotating, orbiting around the sun, the Earth is also rotating on its axis, right? And so, like here we are in the United States, right here, right? How long does it take for the Earth to rotate around its axis? Do you guys know? 24 hours, right? That's why we have night and day. Because if you think about it, so the Earth is spinning around, and at some point it comes out of the dark side of the Earth and comes into the light. That's what it looks like the sun is rising in the morning to us, right? It's not the sun that's moving, it's actually the Earth that's moving. And so this rotation here, we stay in the light all day long as it comes around like this. And then when it comes over here and gets on the dark side, now it's nighttime for us, right? And so that's what's causing the night and day pattern. But as it's orbiting around the sun, what's also happening is the Earth is kind of doing this thing where certain times as it orbits around the sun, the northern hemisphere is pointed towards the sun, right? The northern hemisphere is where we are. Do you guys know what I mean when I say hemisphere? It's like the part that's above the equator, right? This center line in the middle. So the northern hemisphere, certain times of the year, are pointed towards the sun. And other times of the year, the southern hemisphere is pointed towards the sun, okay? As this tilt happens. And so the Earth is kind of doing this thing like this as it orbits around the sun, right? When it's tilted this way, which is for about a quarter of the year, then we have summertime, right? Because the northern hemisphere is closer to the sun. It's aimed towards the sun. When it's more straight up and down, like that, then we have spring and fall. So those seasons are similar, right? Temperatures are similar because we're the same distance from the sun during that time, right? And then during our winter months, it's rotated like this, where the southern hemisphere is pointed more towards the sun, and so it's cooler up here because we're further away. And so that means whenever we're experiencing winter during the summer, when we're experiencing winter during the winter months, like December and January and February, what's happening down here in, say, Australia? If we're tilted away, but they're tilted towards, what season are they experiencing?
Summer.
They're having summertime, right? So we were just talking about this in VBS at church the other day. They celebrate Christmas on the beach during the summer because it's very warm there whenever Christmas is going on, right? That's just bizarre to us. We always think of snow and cold weather and stuff like that during Christmas time, but it's actually December 25th is the warm period for Australia and people down here in the southern hemisphere, okay? So does that make sense how that rotation affects things? So it's actually that tilt, the fact that we're tilted like we are, we're rotating this way, we rotate to the east. So as we're going around, like I said, the Earth is doing this thing where it's kind of going like that, sort of back and forth, as it makes the one trip all the way around the sun. So let's give you some terms that are kind of related to that. And we just experienced one of these things, and it's the summer solstice. Do you guys know anything about the summer solstice? Did you see that in the news that it just happened not too terribly long ago?
I haven't heard about that.
No? Okay. So, have you heard someone say it's the first day of summer? Did anybody hear that recently? Do you guys know when the first day of summer was? It's around June the 22nd. It varies slightly depending on when we actually hit that point, but it's usually around June the 21st or the 22nd. And It is northern hemisphere is fully tilted towards sun. All right, so it happens at a particular point in time where, finally the Earth, as it's rotating around the sun, has tilted as much as it's going to tilt towards the sun, and at that point it's going to start rocking back and going the other way. All right. When that point hits, this is the longest day of the year for the northern hemisphere. Now I'm going to abbreviate this because I don't want to have to write out northern hemisphere. NH does not stand for New Hampshire in this case, okay? It stands for northern hemisphere. All right. Which is where we are. The United States is in the northern hemisphere. What's happening in the southern hemisphere on June the 21st or the 22nd? If we're experiencing the longest day of the year for us, winter, and they're experiencing the shortest day of the year, right? Shortest day for southern hemisphere. So just remember that whatever we talk about as far as the seasons go and the length of days, it's reversed in the southern hemisphere than it is for the northern, okay? So that's the summer solstice. Winter solstice is the opposite time of the year, opposite effect. This is December 21st or 22nd. NH fully tilted away from sun, shortest day of year for us. So if it's this tilt for a certain part of the earth, either towards the sun or away from the sun, that's causing the shortest day and the longest day, then we would expect that there should be two periods as it goes around where the days and nights are equal length. And there are. So there are two periods where we have 12 hours of sunlight and 12 hours of daylight. Like right now we're experiencing, what is it, more like 15, I think? So like 15 hours of daylight right now and 9 hours of nighttime. So this is like best time of the year to get out and do stuff done outside because you got a lot more daylight. So we have special names for those two types of the year, and because it's equal day and equal night, the name, it sort of sounds like equal. The name is called an equinox. So we have the spring equinox. So maybe that's a way to help you remember that. Spring equinox, which is March the 20th or 21st. And autumnal, right, based on autumn, another name for fall. Autumnal equinox, which is September 22nd or 23rd, or exactly between summer and winter solstice, and are the times where we have equal times for day and night. questions about those terms? So if we think about it throughout the year, we just hit June 21st or 22nd. I don't remember which day it was this year. And again, it has to do, the reason it's not always the same is because it has to do with the Earth's path around the sun. And where it hits that particular point, it varies a little bit as we go from year to year. But we just hit the summer solstice, June 21st or 22nd. What's going to be next? What are we hitting next as far as these 4 terms go?
Winter?
No. Look down here, what has to happen before we hit winter solstice? Going from June, then we hit July, August, September. What happens September 22nd or 23rd? The autumnal equinox, right? So we hit autumn, we hit that season. So so longest day, June 21st, 22nd. Earth continues to move around the sun. The tilt as it relates to the sun varies, and we get equal day and night. Autumnal equinox, that's exactly between summer and winter solstice. Earth keeps moving around the sun. We hit the winter solstice where we have the shortest days of the year, about 9 hours of daylight and 15 hours of night. Earth keeps moving around the sun, and we hit the spring equinox, right? And there's a bird that landed like right there and flew off, grabbed onto the screen on the window. Spring equinox is March 20th or 21st. Same amount of day and same amount of night for that on that particular day. Earth keeps moving around, then we hit the summer solstice again, and the process starts all over. Does that make sense? Yep. Okay. All right. So let's talk about latitude and longitude. Make sure we understand that concept. Are you guys already familiar with those 2 terms?
Mm-hmm.
Yep. Do you know, as far as the Earth goes, what is latitude and longitude? Like if you look at this globe here.
Longitude goes down and latitude goes across.
Yeah, perfect. So longitude goes across from north to south, run north to south. Latitude goes around the Earth in the circle. So latitude is measured based on the distance from the equator. Since the equator is the biggest line around the middle of the Earth, right? And longitude, we'll talk in a moment what line we use for longitude, but let's just make sure we know that lines of latitude, imaginary lines running east to west on the Earth. Tell you how far you are from the equator, which is the center line, right? And then lines of longitude. Run north and south. Tell you how far you are from prime meridian. Does anybody know what the prime meridian is? If you said a restaurant in CNN Center in downtown Atlanta, you would be correct. That's not the prime meridian we're talking about here. I only know that because I used to work in CNN Center, so it's a restaurant we would eat at sometimes. but it's based on the name of this name here. And so this is just like we have this imaginary line that runs around the center of the Earth. Let me put this up here so Natalie can see it, right? So we have this imaginary line that runs along, runs parallel to the other latitude lines that runs around the Earth that way. We also have a line that runs around the Earth from north to south, right? And circles the Earth that way. And that's what the prime meridian is, and it actually runs through a line that runs through Greenwich, is how you pronounce it, although it looks like Greenwich, England. And that's where our time zones start. All right, so when we talk about here on the East Coast that we're 4 hours behind or 5 hours behind, depending on whether we're experiencing daylight savings time, we're 4 hours behind or 5 hours behind what? We're 4 hours behind the time in Greenwich, England, which is where the time zones start. Sorry, move all the way here. Rotate around. Give Natalie something to look at while she's waiting for you guys to finish writing. Because she paused the recording whenever we wrote those notes on the board and she wrote them down. So she's just sitting there going, are they ever going to get done writing? So just to make sure we understand, like if we say if we have a latitude measurement that is 30 degrees north, we mean 30 degrees north of the equator, right? So this line here is actually 15 degrees north, this is 30 degrees north, all right? If we say 30 degrees south, we're on the line that's two of the big lines down, so down here. But all that's based on the equator. Okay, and the same thing from longitude. Where is England? England's over here. So I'm having a hard time finding that. Right here. So it's this line right here. This is 0. As far as longitude goes, and so if we go over this way, this is 15, 30, 45, but west, so 15 degrees west, 30 degrees west, but then since here's where the line is as it runs through England, this would be 15 degrees east, 30 degrees east. So that's how we measure longitude and latitude. All right. I'm going to stop